Hi, I'm back again with the part 3 of our quantum chapter with our quantum numbers. So we are at the very end, but quantum numbers are very important. Quantum numbers help us to understand how the electrons arrange in an atom. So basically, these are atomic orbitals, right? I told you the atomic orbitals. So there's can be 1, 2, 3. It goes away from the nucleus. And the atomic orbital, each orbital described by the quantum numbers. So there are basically how to describe this orbital. There are three main, like basically four quantum numbers, but here we're talking about only three. So the first quantum number, principal quantum number, it designates the size, basically talk about the energy of an orbital. Higher the energy, higher the principal quantum number. Angular momentum quantum number. Angular momentum quantum number describes the shape of an orbital. Magnetic quantum number, orientation. What is the difference between a shape and orientation? Shape can be spherical, dumbbell shape, but orientation, there's X, Y, Z planes, which orientation the orbital is at. As I'm going back, oh, I should go down. Sorry. Okay. So, very first quantum number, principal quantum number, very easy to understand. It's away from it's going like if I show you here, let me draw you. So like the other way. Yeah. So the principal quantum number is so if you have the nucleus here, this is my nucleus. 1, 2, 3, 4. N1, N equals 1, N equals 2, N equals 3, N equals 4. Like that. It goes like that. 1, 2, 3, 4 goes up. So it's always integers. And then higher the N, higher the energy. You go to the angular momentum quantum number. It describes the shape of an orbital. Like there are L can be like there are different shapes. Different shapes have different numbers and different name. Like if orbital is a spherical, we call L equals 0. I mean it's S orbital, P orbital, D and F. So that is angular momentum quantum number described in shape of orbital. And then so magnetic quantum number, it describes the orientation. So let's see how these come all together, come to the picture. Where n is 1. When n will be 1 here. Let me show you where n comes 1. So this is my nucleus, n like that. So n equals 1. Where my n equals 1, there's a relationship between n and L. L can be 0. L can be 0 to n minus 1. So L can be, sorry, this is L, okay, I know it's important. L equals 0 to n minus 1. So for the n, it's 0 to 1 minus 1, 0. So L equals 0. What is mean by L equals 0? L equals 0 means if you go here, if you see this one, this slide, this particular slide, L equals 0, that means we have only S orbital. When the orbital that closest to the nucleus has only S orbital. S orbital is spherical shape. When the electron at the closest orbital to the nucleus, its shape is spherical. So then you go to the n equals 1, n equals 2 level. N equals 2 level. L can be 0 to n minus 1 to n minus 1. So 0, n minus 1, 2 minus 0, 1. So L, you have two types of orbitals in the second level, which is S and P. You go to n equals third level, it is 0, 1, 2. So you have S orbital, P orbital, D orbital. It goes like that. And then so quantum number, so this is the S orbital. So this is the n equals 1. So this is the nucleus, okay? N equals 1, n equals 2, n equals 3. So now when n equals 1, you have only one orbital, which is s. You go to n equals 2 level, you have s and p. What is the, so p has 0 and 1. 0 means s orbital, 1 means p orbital. P is, I told you, right? There's a magnetic quantum number. Magnetic quantum number is the orientation. The relationship between L and ML is negative L, positive L. So then, so 0, there's no positive or negative in 0, but when you go to 1, -1, 0, +1. So you have 3 p orbitals. You go to n equals third level, -1, 0, +1, and then d and f. It goes like that. So n equals third level is third orbital after the nucleus, third orbital from the nucleus. So you have s orbital, p orbital, and d orbital. What is this 5 means? It has small, how the electron arrange these in the small orbital. So it called the atomic orbitals, and then the smaller orbitals are here. So let's do an example that's easy. What are the possible values of the magnetic quantum number ml when the principal quantum number is 3? So our n is 3. What is L? Okay. So no, what are the possible values of the magnetic quantum number when the principal quantum number is 3 and the angular momentum is 1? So my question is, so n equals 3, possible L values 0, 1, 2. And they're talking about the 1, this is the 1. L values for the M values negative L, so negative 1, 0, +1. So you have to, so if I ask, what are the possible ML values for the 2, then it's going to be -2, -1, 0, 1, 2. Possible ML values for the L equals 2 level are these. So this is the last quantum number, spin quantum number. Spin is each small orbital, like here. So when I ask you to draw, you draw, okay, S orbital is a 1 box, p orbital is 3 boxes, d orbital is 1, 2, 3. This is the way you can draw it. 5. And each orbital hold electrons. They hold electrons up, little arrow up, and sorry, I can draw it up and down in a one box. So why the half arrow up and half arrow down means when there's a half arrow up, we call positive half, half arrow down, we call negative half. Always electrons are like in a motion. They said it's rotate in the one electron. So always in the small orbital, it contains 2 electrons. Always one rotate to the clockwise, other one rotate to the anti-clockwise. So then it should cancel out. It's nothing. Spin quantum number always +1 or negative, plus half or negative half. If the half arrow up, it's plus half. Half arrow down is negative half. So I want you to show this quantum number a little bit. So the principal, it shows the size, angular shows the shape, the magnetic shows the orientation. So some orbitals, some shape, S orbital is spherical shape, and then this is the shape of the S orbital. I can see this orbital yet. Let me see. Oh yeah, this is so this is P. P orbital is dumbbell shape. S orbital is a spherical shape, and these are some p orbitals, and then d orbitals. So how the energy of an orbital goes. So first, this is the first principal cell. Only you have one s orbital. You go to n equals 2 level, L values. So two shapes you have, S and P. But in the P, S you have only one S, but P can be in three different orientations because P is a dumbbell shape. So P can be like, see, S is a spherical shape, but P is like, P can be like this, like that, like that. We call this is PY, PZ, no, PX, PZ, so like that, okay? So, then each shell, so this is the 2s subshell. If I ask you the right notation, n equals 2, L equals 0, I'm going to use the same diagram, not going to each and every one. If I go to this one, this is the n equals 3, L equals 1, n equals 3, L equals 2. This is, sorry, n equals 3, L equals 1, n equals 3, L equals 2. This one, 4, n equals 4, L equals 0, n equals, because it's P, n equals 4, L equals 1. This is d orbital, n equals 4 because it's always fourth shell. So it's n equals 4 because it's 4, and then L is 2, and then ML is negative L to positive L, negative 2, negative 1, 0, 1, 2. It goes like that. All these diagrams explain that. So I have this question. List the values of L, NL, and ML for each of the orbitals in the 4D subshell. 4D subshell, N equals 4, L equals 2 ml, negative 2 to positive 2. That's the end of quantum numbers, and I have another separate video for quantum numbers. And I want you to, I know it's not easy content, so I want you to study a little bit more, watch my videos, read the book, watch my other video, and then try your questions. And always, it's a good idea to practice questions, and if not, I have given you unlimited attempts. Always you can come back and try to get better score. So I hope this video is helpful for you to understand and be successful in chemistry. Good luck.